I wanted to show you guys another example. Well, one or two. Let's share screen here. There we go. This is kind of a nice one where we can kind of see how this works and maybe do the integrals. Integrals really easy. Okay, so this is the curve, y equals x squared from 0 to 1, and as you turn it around, you get something like that. Okay? Now, if I think about what's going to happen to this, when I break it up into discs, you can see the discs pretty well here. Like they've broken this up into 10, I believe. And, well, they build it out like that. But that's what each of these rectangles is going to look like when you put it around. And let me get into the disc. Let me undo that. Reset. And now let's actually do the problem real quick. So we had, and often what we'll do is just basically, after we're done with these little videos, I'm just going to do it like this, and then I'm going to kind of want to draw it, and I'm going to imagine taking it around the axis and then having something like this. I'm going to have a disc, sort of just like a regular disc like this. Whoops, it doesn't look great. Well, more or less. So your drawing might look pretty crappy, like my drawing looks pretty crappy, but you know, you kind of get the idea, right? So that's why I really like looking at the videos first, because you get to the idea in your head. You're not like attached to this drawing. Anyway, we have y equals x squared, and from 0 to 1. So remember, the volume is the integral of pi r squared d, and really this should be dh, right? Being the height. So this is like the height of the little thin disc, but it might be easier if we just think about it as either dx or dy, depending, because we can do around dy as well, all right? And I'll do one of those in a minute. But if we're going around this way, the radius is y, and then the thickness, sort of thickness of our disc is going to be dx. Disc thickness is going to be dx. So my volume, I'm taking pi, and it's y equals x squared, so x squared squared dx, and x goes from 0 to 1. So I'm basically integrating x to the 4th. So this is very easy, right? So I end up with an answer of pi over 5 for that volume. Now I'm going to show you another one, which is a little bit more, okay, where's this guy? Okay. And we're gonna bump to this. This is the one that wouldn't load in the other one. Here we have a sort of similar situation, and it's still not loading. Oh, come on. I'm going to try it one more time. Otherwise, I'll just do it. Okay, it's x plus 3 and x squared plus 1. Is it? Did it? No, it's dead. Let's try one more time. It's dead. Dead as a doornail. It's here under extra material. Maybe you'll have better luck than me. There's two of them on this page, but this is the one I was trying to get to. Well, at least it might not fully do it, but at least we can see the picture and talk about it. I don't think we're going to get the applet to work, but I want to take a look at the picture, okay? Because it's going to look better than when I draw it. So I can draw the two-dimensional thing pretty easily, right? That's this. Oh, maybe it's going to work. So what they're doing is they're taking this and they figured out that these two curves intersect at the point -1 and 2, right? That's pretty easy because they're two straightforward, simple curves. So in order to get it to work, so there it is in the XY plane. That's this picture here. And now we're going to rotate it around the axis. So we rotate it around the axis. You see we get this shape, which on the outside it looks kind of like a cone, but on the inside it's got this interesting curvature, right? Because that comes from the parabola. So, like, it's quite pretty, but I'm not sure exactly what you would use such a shape for. But in any case, so you have that, and you can see that it has a hole in the middle, sort of, right? Now it's broken, but oh, there it is. So you see it kind of looks like that. It's a neat shape, but in order now to find, I can't stop moving it. I can't stop moving. Okay, whatever, just whatever. It doesn't look good now. Anyway, but in order to find the in order to figure this out, the easiest thing to do is you're going to do the same thing, right? But really, you're going to take the volume of the outside thing, and we're going to subtract the volume of the inside thing. This is really hard to move it around. I'm trying to get back the original shape, like the original orientation, but it's not working. I've turned it around too many times. Anyway, so you can think of it that volume of the outside minus the volume of the inside, but you can also think about if I slice that up, each slice now, rather than being a disc, it's going to be a ring, right? So if I kind of just draw this, I'm going to have something that looks sort of like this, like a washer. Okay, so that's why this is called a washer method, right? Just like a washer that you use when you're, doing whatever you're doing, fixing stuff in the house. Okay, so let me get rid of this and make myself large again. And then we'll do this problem, okay? Which I wrote badly here, but what I want to look at is this outside curve is y equals x plus 3, and this inside curve was y equals x squared plus 1, and they told us, or we figured out, which we could easily figure out, that our x values went from -1 to 2, right? Yeah. Right? Yeah, definitely. So how do you do this when you've got an outside curve and an inside curve? Your volume is you just take the volume of the outside curve minus the volume in the inside curve. So it's pi r squared, but r squared out minus r squared of the inner curve. Oh, you can't see that. It's a little bit too high. All right, so let's do this. Let's write it here. And again, dx in this case, because it's d thickness. This is the thickness, it's in the x direction. So this is the thickness of our washer. Now you gotta be a little bit careful. It's not r out minus r in quantity squared, okay? It's basically the outside disk minus the inside disk. And then this is going to be It's not any more difficult once you have it set up. You just have to remember which is which, but it's going to be a little bit longer than the previous problem, right? Because the outside was this line, and the inside curve was the parabola. And we just integrate that, which I didn't integrate ahead of time. So I'll just do it now, but I don't have a lot of space. All right, so let me do this. Let me erase my picture. That's the problem on them doing this on the Zoom, so the board is a little bit smaller, just to keep it in the picture and make it work. So what do I have here? So I have to work this out. 3 times 2 is 6 plus, right? Plus 6x plus 9 minus x to the 4 plus 2x squared plus 1. So random 3. Okay. So minus x to the 4 minus x squared plus 6x minus 8. Oh, I wanted to integrate, so I get rid of that. Sorry, forgot where I was. Minus x over 3 plus 3x squared minus 8. X from minus 1 to 2. So whatever number this is. Better figure it out. Oh, it's a Zoom meeting. Hold up. Forgot I could, this is so cute. I can just pause. See, I don't want to waste your time. So because I know you don't want to watch me do arithmetic, I did it over here. The answer is 117 pi over 5. There was an error. I wrote minus instead of plus here. But I figured it out when I ended up with a negative answer. And of course, you can't have a negative answer when it's a volume. So you know you did something wrong. So it took me a minute, but what I had somehow just had the wrong sign. Found it. That's the right answer now. It's all good.